Hi class, this is still 5.3. It is just a continuation. It is the formula for at least once, which you will see in your homework. Um, this is a little complicated, so don't be skipping around in this video thinking you can just get the good parts, because this one's a little bit hard. So, we're and another reason is because it's not on the formula sheet. So this is one that you're going to have to memorize. So actually the formula is on the second page. So if you flip over to the second page, it's at the top. It says at least once. So let's just look at the formula and then I'll explain how the heck they came up with this formula. So it says the probability of at least once is so the probability of something happening at least once. So like for instance on that last example we did the probability or getting hit by a hurricane if you live in South Florida. So the probability of getting hit by a hurricane at least once in 10 years, here's the formula. It is 1 minus, so it's a little adaptation of that complement formula, that not formula. So it's probability of getting hit at least once in 10 years would be 1 minus not getting hit, not getting hit, not getting hit, not getting hit, however many times they're talking about. So in the case of living there 10 years, you would have 10 of these strung together out here. Okay, so how the heck did they come up with the formula? Well, that's what I'm going to try to explain on this first page. So go back to the first page. We're going to actually do it without the formula first, the way I like to do it, but then we're going to need a formula because our problems are going to get bigger than just 3 little things on our spinner. So here we go. It says the spinner is spun 2 times. I know I'm going to be doing multiplying because this is 2 events, and so you use the and formula, which is the multiply formula. Okay, it says spinner is spun 2 times. Find the probability of spinning at least 1 green. So the first thing I'm going to do is I'm going to write down every single situation. Remember, this is the reason why we learn formulas, so we don't have to write down every single situation. So, but I'm going to do every single situation. So here's my first spin, and here's my second spin. Okay, so let's just say that we start with red. It doesn't matter what you start with, but this is an organized way of catching all the situations. So let's just say we start with red. Our first spin is a red. Well, how many ways can the second spin happen if that is the first spin? Well, it can be a red and a red. You can spin a red and then you spin another red. Or you can spin a red and then a blue. Or you can spin a red and then a green. Okay, that's all the ways if red starts, but red doesn't have to start. So I'm going to I'm making 2 more columns just because I don't have enough room over there. Okay, so let's pretend that we got a blue first. Okay, well if we get a blue first, how many different ways can we spin the spinner twice? Is we could get a blue and a red, a blue and a blue, or also a blue and a green, and that's all the ways if blue happens first. Okay, well red doesn't have to happen first, and also blue doesn't have to happen first. So what's the other way that can happen first is green. So if we start with green, how many different ways? So we can do green and red. We could also spin a green and then a blue. Then we could also spin a green and then a green, right? And so there's all the ways. All right, so what is the probability of spinning at least 1 green? Okay, well first of all, what's the total number? Out of the 9 different ways you can spin twice, because here they all are, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how many of them have at least a green? Well, I'm gonna change my colors here just to show you. Well, that first one doesn't have a green. That second one doesn't have a green, but this one does. So there's at least one green. Okay? On the next column, first one is a no, second one is a no, but this one has a green. Okay, in the third column, they all have a green. So this one has at least one green. This one has at least one green. And this one has at least one green. So what's my answer over there? It is 1, 2, 3, 4, 5 out of the 9 ways have at least one green. Okay, so so that's going to be part of the way that we can figure out that formula on the next page. Okay, so now let's think about this. Let's think about what's happening, or let's think about these two little questions that they have that we need to answer down here. So it says probability of at least one green in 2 spins. Well, that's exactly what we just did. So that's 5/9. Plus, what's the probability of no greens in 2 spins? Well, go back up there and look. If you have no greens in 2 spins, well, there's one that has no greens in 2 spins. There's another one that has no greens in 2 spins. There's another one that has no greens. And then there's another one that has no greens. And if you notice, those are all the other ones besides the at least one. So that's going to be 4, 1, 2, 3, 4 out of the 9. And what are those going to equal up to? They're going to equal up to 1. So the probability of at least one green plus the probability of no greens, those are always going to be the flip side of each other, and they're always going to add up to 1. So if you scoot down a little bit.
Oh, so long.
That's okay.
I saw him raising his hand for like 5 minutes.
I know, he was being very polite.
You should have interrupted.
That's okay. So, let's just do a little algebra on this, because what we're trying to do is figure out what the at least formula is. So, I want to try to get the at least piece by itself. So, I'm going to subtract the probability of no greens from each side. We're just doing algebra. And that leaves me the probability of at least one green equals 1 minus the probability of no greens. All right, so now what's the probability of not spinning greens in 2 spins? So this is where, day before yesterday, when we were talking about the fact that sometimes the word and is not included in the problem, you have to understand that it belongs there. And here's a good example. Because when they say what's the probability of not spinning a green in 2 spins? Well, what's the probability of not spinning a green in 1 spin? 2/3. And what's the probability of not spinning a green in the 2nd spin? It's also 2/3. So the probability of not spinning a green in the 1st spin and the 2nd spin, so it's multiplication, that gives you 4/9, which is exactly what we got when we made the picture. So the probability of at least one green in 2 spins is going to be 1 minus 2/3 times 2/3. Or 1 minus 4/9, which equals 5/9. All right. Yeah. So here is your formula written out for you at the top. The probability of something happening at least once is 1 minus the probability that it doesn't happen times the probability that it doesn't happen times the probability that it doesn't happen, however many times that you're going to spin. So in this case, we're going to spin, what's the probability of spinning a green at least once? So that's going to be 1 minus the probability of no greens at all. So that's going to be 1 minus the probability of no greens in the 1st spin is 2/3. Probability of no green in the second spin is 2/3. Probability of no green in the third spin is 2/3. And in the fourth spin. Now, what would have been an easier way to do that?
To the fourth one.
Yeah, to the fourth power. So that would be 1 minus 64 over 81. Because 2 to the fourth is 64 and 3 to the fourth is 81. So I don't have my calculator sitting right here, but that would be 81 over 81 minus 64 over 81. So 17 over 81. Is that right? Which is something as a decimal. I don't know. If I find my calculator, I'll tell you.
One 0.209.
Jackson, did you do that in your head?
No.
Oh.
So, oh, that's wrong. That's my fault. Because I was like, why does it come out to be that? This should be 16. Well, why did you tell me that? I was like, why is it so big? Okay. 1 minus, so that's 81 minus 16. Oof, that makes me feel better. That's much better. $65 out of 81. Now I feel better. Okay. Phew.
2002.
That's right. 802. All right.
And then it's what?
It's 65 over 81. It was my fault. I did 2 to the 5th instead of 2 to the 4th. Or actually, I did 2 to the 6th. I don't know where my head is. I don't know. Feels like it should be Friday.
No, I don't.
Okay. A coin is tossed 10 times. Find the probability of flipping at least one head. So at least one head is going to be 1 minus the probability of no heads. So first of all, 10 times. What is the probability of not flipping a head?
Half.
Right. So probability of no heads is going to be 1/2. So if I'm flipping 10 times, at least one head is going to be 1 minus the probability of no heads to the 10th power, because we got to do it 10 times.
Yep. And the fraction is 1 over 1,024.
Wow.
No, not the 1 over
This
2
is
is
back.
so it's 1 minus that, which is 1,023 over
Which is
0.999.
0.999. This speaks to the law of large numbers, like we talked about, because that's a pretty slim possibility or that's a pretty strong possibility that you're going to flip at least one head. If you flip a coin 10 times, there's a real strong possibility at least one of those times it's going to land on heads. That's almost 100% probability. All right. Last. The Christmas bulbs. I don't know where my page went. There it is. All right. So Christmas lights are often designed with a series circuit. This means that if one bulb burns out, the entire string goes black. I hate that. It drives me nuts. Suppose that the lights are designed so that the probability that a bulb will last 10 years is 0.995. The success or failure of the bulbs are independent of each other. What is the probability that in a string of 100 lights, all 100 will last 2 years? Well, the probability that it will last is 0.995. So what's the probability that all 100 are going to last 2 years? Probability that they all last is going to be 0.995 times 0.995, blah, 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 blah,
Power.
to the 100th power.
Point 60577.
606. All right. That explains why all the Christmas tree lights go out about 2 years into owning your Christmas tree. So, what is the probability that at least one bulb will burn out in those 2 years? Well, probability of at least one not lasting, because it's going to burn out, equals 1 minus the probability that they all last. And we just calculated that. So that's 1 minus 0.606.
Which equals 0.395.
That's it. Now you should be able to finish the rest of my labs. I mean, you might have been able to do it anyway. You probably might have remembered, but